Good day, everyone. Our lesson for today is all about matrices. Matrices by graph, matrix addition, matrix subtraction, scalar multiplication, and transposition. Okay, so the theory of matrices include algebraic operations between two or more matrices. Our study of matrices will focus in showing how they are used to describe and solve linear systems of equation. We will explore the different definitions of matrices and try to understand its application in real-life situation. Definition 2.1: An M times n matrix A is a rectangular array of Mn, real or complex, numbers arranged in M horizontal rows and N vertical columns. So, ayan no? Horizontal row is the M and the vertical is the N. Wherein, meron siyang ith row at saka jth column. I row and j column. For the I, it represents the row and j represents the column. So this is a sample of, or let's say a representation, a model representation for a matrix A. The ith row of A is or A sub I1, A sub I2, ellipses up to A sub IN, such that I is greater than or equal to 1 and less than or equal to M. The jth column of A is, this is a column. So A sub 1j, A sub 2j, ellipses up to A sub mj, such that j is greater than or equal to A, but and less than or equal to n. Okay, we shall say that A is m by n, written as m times n. If m is equal to n, we say that A is a square matrix of order n. N, tama naman, di ba? Pag ang m tsaka n ay equal, so they are square. And the number A sub 11, A sub 22, ellipses up to A sub nn form the main diagonal of A. We refer to the number A sub ij, which is the ith row and the jth row column of A, as the jth element of A, or the quantity I and j entry of A, and we often write that number 1, this one, that one, as A equals square bracket of A sub ij. So, yun yung representation ng I and j element. Example, let A is equal to square bracket 1, 2, 3, negative 1, 0, 1, B, square bracket 1 plus I, 4I, 2 minus 3I, this I is a complex, minus 3, C, square bracket 1, negative 1, 2, D equals square bracket 1, 1, 0, 2, 0, 1, 3, negative 1, 2, E equals square bracket 3, F equals square bracket negative 1, 0, 2 are all matrices. Then A is a 2 by 3. It is a 2, that's for the M, and for the N number of rows, it has 3 rows, so 2 by 3 matrix with A sub 12 equals 2. So 12 means to say first row, second column. Am I right? Yeah. First row, second column. The first row, at the same time, the second column of A is 2. First row and third column is 3. For A22, that's second row and second column, that's 0. And second row and third column, that's equal to 1. B is a 2 by 2 matrix. This is a 2 by 2 matrix. This is considered as one variable or one element for 1 plus I. With B sub 11 equals 1 plus I, B sub 12 equals 4I. B sub 21 equals 2 minus 3I, and B sub 22, which means second row and second column, equals negative 3. C is a 3 by 1. It is a 3, meant to say the number of rows. It has 3 rows and 1 column matrix with C11 equals 1, C21 equals negative 1, and C31 equals 2. D is a 3 by 3 matrix, which means it is a square. So E is a 1 by 1 matrix and F is a 1 by 3. This is a 1 by 3 matrix. 1 row and 3 columns. In D, the elements D11 is equal to 1, D22 is equal to 0, and D sub 33 is equal to 2 form the main diagonal. So this one is the main diagonal. It is, since it is a square, it has a diagonal elements. An n by 1 matrix is called an n vector. So it is an n vector, which means it has a n rows and 1 column. Okay? So meron siyang n row, just like this one. It has many rows but only 1 column. So that is an n vector. And is denoted by lowercase bold-faced letters. Okay? When n is understood, we refer to n vectors merely as vectors. So example, u is equal to the square bracket 1, 2, negative 1, 0 is a 4n, which means n is the number of rows vector. So it has a 4 vectors. And v is equal to 1, negative 1, 3 is a 3 vector. It's not 3 vectors, no? Kasi it's a compound word. The n vector, all of whose entries are 0, is denoted by 0. If A is an n by n matrix, then the rows of A are 1 by n matrices, and the columns of A are n by 1 matrices. The set of all n vectors with real entries is denoted by r raised to n. And then, similarly, the set of all n vectors with complex entries is denoted by C raised to n. So kapag yung mga real entries niya, like this one, these are real entries, real numbers, so they are R raised to n. But if they are complex, just like this one is a complex, yung may I, so that is denoted by C raised to n. Okay, that is n vectors. And we consider n vectors if it is n by 1. Okay, another, by graph. So if you still remember the graph theory, by graph, we mean a set of points called nodes or vertices, some of which are connected by lines called edges. So this what we call the vertices, these points, and yung mga lines called the edges. The nodes are usually, or the vertices are usually labeled as P sub 1, P sub 2, ellipses up to P sub k. So these are example of vertices P sub 1, sub 2, sub 3, and sub 4. And for now, we allow an edge to be traveled in either direction. So pwede siya mag-direct in different directions or mag-move. One mathematical representation of a graph is constructed from a table. For example, the following table represents the graph shown. So, for instance, P sub 1 and P sub 2, let's write this one. This is a table representation for the given graph. So we have P sub 1, P sub 2, P sub 3, and P sub 4. The same is true with this, P sub 1, 2, 3, and 4. So let's say P sub 1 and P sub 2. How many edges do we have? For P sub 1 and P sub 2, P sub 1 and P sub 1, we have only, 0 for that. We don't have P sub 1 and P sub 1, kumbaga self lang niya. It's only a point. For P sub 1 and P sub 2, P sub 1 and P sub 2, this is P sub 1, we have 1 edge. P sub 3 and P sub 1. P sub 1, P sub 3, we don't have edges kasi walang nagko-connect sa kanila, no? Directly. So 0. P sub 4 and P sub 1, we don't have a line here. P sub 2, we have, and P sub 1. P sub 2 and P sub 1, one line. P sub 2 and P sub 2, that's 0. P sub 3 and P sub 2, that's equal to 1. And P sub 2 and P sub 4, that's 1 also. For P sub 3, we have 0, 1, 0, 1, and P sub 4 is 0, 1, 1, 0. So the ij entry is equal to 1 if there is an edge connecting vertex P sub I to vertex P sub j. Otherwise, the ij entry is equal to 0. The incidence matrix A is a k by k matrix contained or obtained by omitting the row and column labels from the preceding table. The incidence matrix for the corresponding graph is this. So this is the incidence matrix. So the representation of this graph for that is or the representation, the resulting representation of this graph, which is this one table, turned into this one matrix, k by k matrix, which is A equals square bracket of 0, 1, 0, 0. We get it from here. Then 1, 0, 1, 1, 0, 1, 0, 1, and 0, 1, 1, 0. Okay. So that's only a representation, my dear student. Don't be confused, no? It is another representation for the matrix. Now, definition 2.2. So we're not yet down to the discussion about the definition of matrices. 2m by n matrices A is equal to the square bracket of A sub ij and B is equal to square bracket of B sub ij are equal if they agree by entry, that is if A sub ij is equal to B sub ij. And for I is equal to 1, 2 ellipses up to m, and j is equal to 1, 2 ellipses up to n. So pag nag-agree daw sila ng entry, they are equal. Now let's try. The matrix says A is equal to 1, 2, okay, square bracket of 1, 2, negative 1, 2, negative 3, 4, 0, negative 4, 5, which is the same, or it is a square matrix, and B is equal to 1 to W 2x4 y negative 4 z are equal if and only if W is negative 1, x is negative 3, y is equal to 0, and z is equal to 5, which is obviously they are equal. These two matrices are equal. Now, let's have now the operation for the matrix. The first one is the addition. So definition, if A is equal to square bracket of A sub A sub ij, and B is equal to the square bracket of B sub ij are both m by n matrices, then the sum A plus B is an m by n matrix, matrices, or matrix. C is equal to square bracket of C sub ij, denoted by C sub ij is equal to A sub ij plus B sub ij. So the result is what we call that. No? Yun yung ibig sabihin ng result na yun. Ang C sub ij, makukuha mo siya kapag pinag-add mo ang elements ni A tsaka si B, such that I is equal to 1, 2 ellipses up to m, J is equal to 1, 2 ellipses up to n. Thus, to obtain the sum A and B, we merely add corresponding entries. So halimbawa, we have a square, what do you call this? Similar entries. Okay, similar number of entries, which is A is equal to the square bracket of 1, negative 2, 3, 2, and negative 1, and 4. And for B is equal to the square bracket of 0, 2, 1, 1, 3, negative 4. So to add A and B, the two matrices should have the same number of elements. So A plus B is equal to 1. Parang ganito lang siya. It is just like, parang diretso lang. Kumbaga, parang itong B, ipapatong mo lang siya kay A. Tapos yung kanyang kaharapan, if you imagine what I'm talking about, yun ang ipag-a-add mo. So, similar column and similar row position. So, 1 plus 0 is this one. So, that's equal to 1. Negative 2 plus 2, that's equal to 0. 3 plus 1 is equal to 4. That's it, that one. 2 plus 1, this is 2 plus 1, so 3. Negative 1 plus 3, negative 1 plus 3, that's 2. 4 plus negative 4, 4 plus negative 4, that's 0. So this is the resulting sum, or the sum of the two matrices A and B with equal number of elements. So yun yung addition of matrices. Now, let's have another example. For this one, we have negative 2, 0, 4, 3, negative 10, 12, 3, negative 2, negative 2 plus, negative 4, 6, 0, negative 15, 2, negative 4, 6, 7, and 1. So to start with, we can now combine the two. So we have negative 4, negative 4, 4, 0 plus 6, 4 plus 6. Maybe you are wondering bakit negative to. Negative 2 plus negative 4. So pareho din naman, negative din naman yung ilalagay natin, right? Then 3 plus negative 15, and then since positive negative, that's negative din. So hindi na tayo nagdodoble no, nang nilalagay. Negative 10 plus 2, 12, negative 4, 3, plus 6, negative 2, plus 7, negative 2, plus 1. Then do the operation of addition or subtraction, or the what they call the addition of integers. So we will get negative 6, 6, 4, negative 12, negative 8, 8, 9, 5, and negative 1. Another, we have this one, 3, negative 4, 0, 2 plus 4, 6, 8, 0, 2, and 4. Unfortunately, this 2 doesn't have the similar elements. So, we can't add because they are different dimensions. Okay? So, for number 3, they are now similar, but at this point, as you can see, it's subtraction. So, we have this one. Okay? Same is true. In addition and subtraction, they should have similar elements, both the two matrices. So for this one, 2 minus negative 4, negative 18 minus 2, 20 minus negative 5, and negative 5 minus 1. So this is the representation of what I'm talking about. Then do the operation and you will get 6. For 2 minus negative 4, that's 6. Then negative 18 minus 2 is negative 20. 2 minus negative 5 is 25, and negative 5 minus 1 is negative 6. Another one for the subtraction, we have negative 3, 10, 2, negative 10, 8, negative 6, 0, 1, 0, minus 5, 4, 3, 2, 1, 0, negative 8, negative 10, negative 4. You can post this to answer the equation and then try to compare it with my solution. So this is now the operation that we're going to do with our square matrices. So we have negative 3, negative 5, 10, negative 4, 2, negative 3, negative 10, negative 2, 8 minus 1, negative 6 minus 0, 0 minus negative 8, 1 minus negative 10, 0 minus negative 4. So the resulting answer, or the result, I mean, is negative 8, 6, negative 1, negative 12, 7, negative 6, 8, 11, and 4. Now, for the scalar multiplication, definition, if A is equal to the square bracket of Aij, or A sub ij, is an m by n matrix and R is a real number, then the scalar multiple of A by R, or Ra, is the m by n matrix C equals square bracket of Cij, or sub ij, where C sub ij is equal to Ra sub ij. If you get what I'm talking about, ito yung kumbaga, the R is the real number and we just multiply it. Parang it is similar with distributive property. So such that I is equal to 1, 2, ellipses up to m, and J is equal to 1, 2, ellipses up to n. That is, the matrix C is obtained by multiplying each entry of A by R. And that's what we call, in mathematics, we call it the distributive property. Now we have this one, negative 2, so we have a matrix of 4, negative 2, negative 1, negative 3, I'm sorry, 7, negative 3, and 2. So we just distribute negative 2 to all these numbers inside this matrix. So we have negative 2 times 4, negative 2 times negative 2, negative 2 times negative 3, negative 2 times negative 7, negative 2 times negative 3, and negative 2 times 2. So we do the operation of multiplication here. So we have negative 8, 4, 6, negative 4, 6, and negative 4 as our final answer for the scalar multiplication. I hope you get it. Now, let's have another Okay, we have another example, I think. The scalar product of a number k and a matrix A is a matrix denoted by Ka. They're obtained by multiplying each entry of A by the number k. The number k is called a scalar in mathematical notation. Ka is equal to the square bracket of Ka sub ij. Parang yung sinabi ko lang kanina. Now, example. Find the negative 1 of the A matrix where A is equal to negative 1, 2, 3, 6, negative 7, 9, 0, negative 4, 8. For the solution of this, so mention negative 1, parang dito ang nakikita ko is gagawin mo lang, ibahin mo lang yung sign ng mga given matrices, right? So for negative 1, ito, lalagay lang natin siya. So, negative 1 is positive 1, negative 1 and 2, negative 2, negative 1 and 3, negative 3, negative 6, negative 1 and 6 is negative 6. This is positive 7, negative 9. 0, because 0 is neither negative nor positive, negative 4 and positive 8. Negative 8, I'm sorry. Okay, so that this is the result of the given matrix wherein it is multiplied by negative 1 as part of the scalar multiplication process. Now, perform algebraic operation in matrices. So I have here the given. So we have A equals 2, negative 3, 0, and 5, 7, negative 1 half. And C equals 7, negative 3, 0, 0, 1, 5. B is equal to 1, 0, negative 3, 1, 2, and 2. So then D is equal to 6, 0, negative 6, 8, 1, and 9. Carry out each indicated operation or explain why it cannot be performed. So there are some here na hindi pwede. Okay? For instance, let's have A plus B. A plus B. Okay, for the A plus B, we have 2. And this is the number. So we have 2 plus 1 is 3. Negative 3 plus 0 is negative 3. 0 plus negative 3 is negative 3. 5 plus 1 is 6. 7 plus 2 is 9. Negative 1 half plus 2 is 3 over 2. I hope you know how to add fraction. Okay? Then C minus D, we have 7 minus 6 is 1. Negative 3 minus 0 is negative 3. 0 minus 6 minus negative 6 is positive 6 kasi minus minus. 0 minus 8 is negative 8. 1 minus negative 1 is 0. 5 minus 9 is negative 4. For letter C, C plus A is undefined because we can add matrices of different dimensions. C and A, let's see again what is C. C and A are different dimensions. No? Magkaiba sila ng dimension. It is a 3 by 2 matrices. This one is a 2 by 3 matrix. Okay, for 5a, this is a scalar multiplication. So this is 5 and then the given matrix. So we have 5 times 2, 10. 5 times negative 3 is negative 15. 5 times 0 is 0. 5 times 5, 25. 5 times 7 is 35. And 5 times negative 1 half is negative 1 over 5. Negative 5 over 2. Okay, I hope that's clear. Okay, thus far, addition of matrices has been defined for only 2 matrices. Our work with matrices will call for adding more than 2 matrices. Theorem 1.1 in section 1.4 shows that addition of matrices satisfies the associative property, such as A plus quantity B plus C is equal to A plus quantity of A plus B plus C. If A and B are m by n matrices, we write A plus negative 1B as A minus B and call it the difference between A and B, just like what I've thought in the previous section. So to make it clear for the subtraction of the 2 matrices, so let's have A and B matrices. So we have the equal matrices, 2 matrices here. So we have A minus B. So 2 minus 2 is 0, 3 plus 1. Why is it 3 plus 1? Because 3 minus negative 1, since minus negative 1, magiging plus siya. Negative 5 minus 3, 4 minus 3, 2 minus 5, and 1 plus 2. Again, 1 plus 2, it is negative here, pero naging plus siya because that is 1 minus negative 2. Okay? And the result is 0, 4, negative 8, 1, negative 3, and 3. After the addition, scalar multiplication, and difference, between the matrices, let's have now the transposition. If A is equal to the square bracket of A sub ij is an m by n matrix, then the transpose of A, such as A raised to t, is equal to the square bracket of A sub I j raised to t, is the n by m matrix defined. Okay? Kumbaga, as you can see, m by n. So, magpapalit siya, magiging n by m. Matrix defined by A sub I j raised to t is equal to A sub ji. Thus, the transpose of A is obtained from A by interchanging the rows and the column. Example, we have here different matrices. Okay, we have A, B, C, D, and E. Now, the transposition of A raised of A, matrix A, or A raised to T. Kung napapansin nyo, yung technique dyan, ganito lang. Yung first, yung row, gagawin mong column. So, 4, negative 2, 3. Gagawin mo siya. 4, negative 2, 3. 0, 5, negative 2. 0, 5, negative 2. Did you get it? For B, transposition of B is 6, 2, 4. So, 6, 2, negative 4. I'm sorry. There's something wrong. It should be negative 4. 3, negative 1, 2. 0, 4, 3. 0, 4, 3. So, from a row, magiging column siya. Okay? For letter C, transposition of C, magiging 5, 4, ang column, negative 3, 2, and 2, negative 3. And for the D, transposition of D, we have 3, negative 5, 1, column, so patayo siya. It is a 3 vectors, vector. And then for E, which is a 3 vector, so magiging one row lang yan. So 2, negative 1, 3. So 2, negative 1, 3. So ganun lang yung transposition, okay? Unahin mo yung row at gawin mo siyang column. Okay, ganun yung parang easiest way, parang ganon, para mas madali mo siyang makuha. So that's all about for the matrices. Matrices by graph, matrix addition, matrix subtraction, scalar multiplication, and transposition. With that, thank you very much for listening.